very good morning to all of you. Thank you for joining our fourth webinar series. And this webinar, we have a very renowned speaker, and we are thankful enough to, to sir for joining the fourth webinar. And before starting the introduction, I would like to give you a few instructions. I request all the participants to please put your full name as the username in the window, so that it would be easy for us to take the attendance, as well as it will be easy while collecting the feedback forms. So we request all the participants to kindly put your full name as your username. Okay. So, and the feedback forms will be passed to all of you in between the sessions in the chat box. It will be passed multiple times. So we request you to fill in the feedback forms, because based on the feedback forms is when we are preparing the e-certificate. So we kindly request all of you to please, add the feedback form while it is being sent in the chat box. Thanks a lot. Enjoy the talk. All the best to all of you. So now I request Anushka. I request Anushka to kindly introduce our renowned speaker.
A warm welcome to everyone. Thank you for joining us for today's webinar. Today, our presenter will be discussing about the significance and prospects of civil engineering. Okay, now without any further delay, we will turn the time over to our presenter. Our presenter today is Dr. Saju Menacherry. Dr. Saju Menacherry is a reservoir quality geologist with more than 18 years of international experience in the oil and gas industry, with an integrated approach for reservoir quality characterization and prediction for exploration, field development, and production optimization. He has 4 years experience in mentoring and academic supervision of PhD, MSc, and honors students in University of Adelaide, especially in research and training of students in sedimentology, stratigraphy, sandstone diagnosis, and reservoir quality. Also, he has 3 years experience as geochemist and quality assurance chemist in Australia, and 8 years experience as geologist in the mining sector in India. He holds a PhD in petroleum geology from University of Adelaide, Australia, PG Diploma of Personal Management and Industrial Relationship from University of Annamala, India, MSc Geology from Kerala University, India, and BSc Geology with Chemistry and Statistics as subsidiaries from University of Calicut, India. He has co-authored over 20 reservoir quality characterization reports and reservoir quality risk assessment reports, and co-authored over 15 referred articles and more than 35 international conference presentations. He has co-chaired for AAPG International Conference Session, Plastic Diagnosis Group, and other international conferences. He was awarded the Best Runner-Up Poster Presentation Award from SCPM and AAPAG International Conference in 2006. His professional affiliations are in AAPAG, SCPM, and PESA. Dr. Saju is an internationally recognized and enterprise-wide subject matter expert, advising and mentoring on workflow development and best practice in reservoir quality and sedimentology. He has considerable experience integrating reservoir quality and clastic diagnosis aspects of rock properties, formation, evaluation, well log sequence stratigraphy, basin modeling data, petrophysics, geophysics, and geomechanics data, production chemistry, and production data within integrated multidisciplinary teams at all stages from exploration and development of production. He recognizes and reaches out to an eclectic crowd of engineers and influences them to perceive the value of a more integrated approach of geology and reservoir engineering for the best practices. Now, I kindly request Dr. Saju Menacherry to continue his presentation. Thank you.
So I'm going to share my slides first. Oh, okay. Hope everyone can see my slides.
Yes, sir. Yes, sir. It's fine.
Okay, that's good. Thank you. I'll reduce the number of people I can see. Just a second. Make sure everything. Yeah, I mean, in my screen, I can see all other people listing, so I can't see my slides properly. So I was making that into a corner. Now I'm starting my talk. My talk today is about significance of geology in civil engineering and recent research areas. Before to start my talk, I want to thank especially Anjali Gopakumar, Gautam Sarang, and Mohan Kupasamy. First thing, they invited for this webinar series talk, and I accepted that. And yeah, I mean, inviting for me to doing all these good webinar talks, I have to thank these three people. Also, I extend my thanks to students and staffs of VIT who are attending the webinar conference or webinar talk. This is a great thing. It's always appreciated to give more chances to understand and able to study things from different parts of the world, or different researchers or teachers or whoever it may be from different parts of the world, to integrate into this information for the students. So thanks for all these activities. So I'll start my talk from two main sections. The first, I'll start with the significance of geology in civil engineering, geology disciplines. So what are the geology disciplines that can give information to civil engineers in their new projects? So we will go through around 7 of the basic geology disciplines that can give you the information into civil engineering, which is structural geology, hydrology, geophysics, geomechanics, petrophysics, geochemistry, petrology, and mineralogy. So I'll go through in detail all of these things in coming slides. Also, the second phase or the second stage, I'll more talking about recent research areas, integrating geology and civil engineering, which is more related to the latest developments such as urban and landscape design, slope stability and landslides, and again, innovative application of geophysics in civil engineering, integrating petrology in civil engineering, integrating geologic models and artificial intelligence. That's one of them I like the most. And infrastructure innovation in civil engineering using geology. So we will go through all of these things in detail in coming my slides. So civil engineering. Do you think I'm going to take more description or talk on civil engineering? No, probably not, because you guys know more than me. Even a first-year student can talk to me more civil engineering things than what I know. Even I learned civil engineering in my master's syllabus or master's curriculum while I was doing in Trivandrum. So I know civil engineering. I know what they are looking, all of that. But still, I'm not going to talk about any civil engineering with you guys. You all know all of that. But I would like to talk to you about geology. Do you think this is so crowded? It's so complex about geology. You can see in this information like it's a sedimentary, earth, rock, geology, boundaries, layered rocks, metamorphic, igneous. Seems to be so complicated, isn't it?
Yes.
Ah, yeah, that's right. Like, I mean, geology is so complex. So why can't you then put it into a simple word? So simple things. So we will make it a geology as a simple things. Then you will be or everyone will be so happy. So when we talk about the civil engineering, which means construction, that is on earth. So earth means geology. In geology, we see mainly 3 rocks, like igneous, metamorphic, and sedimentary. And the soils that can be unconsolidated sediments and clay. So it's simple. But again, I'm going to talk about like what people think. So some of them thinks it's like igneous erodes to sedimentary. So all the igneous rocks, then they weathered and eroded to sedimentary. Then someone say, no. The igneous melts metamorphic. Oh, So some others say, what? Metamorphic altered sedimentary. So there are different approaches from different people on how the rocks are related in the geology or in the earth. So again, I'm showing this is a rock cycle. So igneous, metamorphic, and sedimentary. So within this one, you can see a number of combinations and different processes you called different rock types. So there are, basically these are the three ones, and there are more rock types. Again, I'm not going to take more classes on that, because you all know that either you learned it or you will be learning from your professor. So I want to make it so simple. I'm talking about like a rocks, which comes from igneous or intrusive or extrusive, sedimentary clastic or carbonates, metamorphic, it's foliated, non-foliated. At the moment, I'm putting as a very common or very easy way to classify our rocks. So what geologic information do civil engineers are looking for? When a geologist are talking to a civil engineer in any projects, what they are looking for, what they want to know about it. So the geological and topographical maps are the essential for understanding the advantages and disadvantages of all possible sites, also helping planning the projects. So this is a starting of any projects. At the time, you want to know the geology of the area and what are the different geological features in that area. So when you move to the next step, we want to know a bit more, such as structural geological features, faults, fractures, joints, beds, faults, state of weathering and loss of cohesion, relative compactness of the rock mass, intensity and orientation of the various sets of fractures, bedding planes, joints and faults, relative abundance of shale layers, bedding orientations, susceptibility to moisture content change during and after construction, swelling pressure, compressibility variation. It's look like a lot. Yes, you need all this information. These are the main informations or a part of information that's given by a different geologist or like from the different disciplines of the geology. Then if you look in more detail, you need the rock mass strength, deformability, porosity and permeability. Then like if you are looking for the tunnel projects with shallower or deeper, so you need a more shear strength. All these things you need for designing when you are looking for a different construction or like a civil engineering projects. Again, the knowledge of the nature of the rock in specific area and zones of fractures and weakness is necessary for tunneling and determining the stability of cuts and slopes. So again, one of the other important one is the groundwater, especially in the excavation works. Understanding soil erosion, transportation and deposition of surface water helps in soil conservation, river control and coastal works. So you want to know the groundwater mainly at different areas. So that's also important thing. So when you are on a construction material, you have to see what is the shearing strength, crushing, such as from gravel, sand, crushed rocks, etc. So look like that's a lot of information you need in any type of your civil engineering constructions or civil engineering projects. So does it stops there? No, there are more information you can add into these things. So that's all comes from different disciplines of geology. So what do you think about geology or geologists? They are rock stars. Is it not right? They are looking all these rocks, and they are real rock stars. I don't know whether you agree with me or not. If you don't agree with me that, I'll put it like this way. Geologist rock. Okay. I don't know whether you agree or not. If you don't agree now, we will come to a agreement, the last page of my talk. Then we both will be agree with that. Okay. So I'm starting more deeply to more serious to talk about like my disciplines of geology, where all the civil engineers can approach and get all this information. I'll start with my structural geology. I put it in such a way that it's not in an importance order. They are all important, but I put it like as a major one to the minor one, or a bigger structure to the minor structure. When I look into the structural geology, it's a big area, but when I look into the petrology and mineralogy, that's more specific. So we will go through it, and you can see the differences. In structural geology, what are the information you are looking from a structural geologist or a geologist working with any civil engineering projects? They are like looking for the faults, fractures, joints, beds, faults, channels, etc. Where do you apply all these things in your projects? Similar like bridges, dams, highway cuts, tunneling, high-rise buildings, etc. Surveys on the characteristics of fracturing, faults are the factors affecting the genesis. So I put two pictures, irrespective of the importance of what you learned or not, which is the major one is like a dam construction. You need a lot of information from a geologist, from what the geology look like and what the structural to groundwater, everything. So it's not only from the structure geology, you are adding the geological information into the dam site or dam construction. Again, one of the, instead of putting every single one as like a fault, fractures, I'm just putting a fault in such a way that to see an example, you get the informations like where it can be a normal fault, reverse fault, slippage, whatever. So these are the information you can get it from your geologist to apply or to design in your new projects on your civil engineering area. The characterization of the bedrock fracture network and identifying the structural controls of the bedrock properties, assessment of the stability of the bedrock structures for risk analysis. I mean, you can add more things into that to the information, but structural geology gives you a lot of information regarding the designing of the projects to de-risking or risk analysis, etc. And also I'm just showing two photographs from rock structure, like this is a folding, this is faulting, you can see. So what these all applies in your construction. So how do you analyze all these features, geological features, and consider in your area? So that's all I want to tell you about the structural geology. Structural geology deals with all these things and to make aware of the risk, advantage and disadvantages of the area. So when I move to hydrology, what are the hydrology things? Like, I mean, hydrology aspects has an important role in design and operation of water resources engineering. Projects like irrigation, flood control, water supply schemes, hydropower projects, even to the slope stability. Also, that can be applied in hydraulic fracture, hydraulic structures like dams, bridges, tunnels, headworks, spillways, culverts, etc. So there's a lot of application where your hydrology information comes from. So again, these are the two photographs I'm showing the importance of hydrology in a dam. You have to know the amount of the surface runoff to the groundwater, and how much water is holding in the rock, everything. These are all advantage or added information to the very good construction. And again, here the stability, the importance of hydrology. As you know, the slope will be, or like, the landslides happens when the condition, the water within and the aquifer or the groundwater makes the difference. I'm not going to talk more about landslides at the moment, but I'm saying to make sure to understand the things, to see where is the best stability and where's the worst stability, or like a stop stability comes from your hydrological informations. Then more importantly, the recent advanced environmental pollution control and planning and execution of water resource development projects, you need all these hydrological information. Other projects like urban water distribution systems, stormwater, sewers, flow control systems for highway development, flood wave propagation, soil conservation, and aquifer management. All these you need the hydrological information into that. So I'll move to the another one, geophysics. How the geophysics can help you to get all the information what you need in your construction. So techniques such as seismic reflection are useful in delineating boundaries between weathered superficial deposit and deeper bedrock, or for defining the extent of alluvium in buried valleys. Which means if you do that seismic surveys, you can see from the top to a distance where, according to the seismic reflection, to get good amount of understanding of the rock types and lithology, or the weathered to non-weathered condition of the rocks. And even you can see around 3 kilometers or 3,000 meters to 4,000 meters in oil and gas industry. That's one of the latest technology. They can easily could understand where the oil is actually sitting. So when you are doing the construction and civil engineering, even you don't need to be that deep, like to 3,000 meters. But if you are looking for 200 meters, that's very clearly you can see the variations in lithology and the porosity, permeability, variations that you can identify everything in a very shallow area. Again, the cross-hole seismic techniques and tomography are powerful tools for interpolation between boreholes and for exploring and extent of significant structural features or lithological boundaries. In these three figures, I'm explaining a bit more on what kind of seismic or geophysical acquisition, or like a geophysical data acquisition. So as you see in the first one, the different geophysical instruments is being deployed to get the seismic waves through the subsurface, to get what kind of lithology or what kind of rocks types are being seen in at different depths. So the third one, I'm just showing like with a color denotes different types of sediments or rocks. And you can clearly see how good you can see map out the depth where these different various types of rocks being deployed or being seen, and what needs to be done according to your project. So you can change your project's plan with respect to all these lithology or the rock types. So characterization of the mechanical properties of soil and rock, such as shear modulus, bulk density, porosity, as well as lithology and patterns of fracturing and weathering. Example, fracture orientation, depth to bedrock, fault location. You can easily find out all this information from a geophysical prospecting. Seismic methods are the most well-established approach with electrical resistivity and electromagnetic techniques. So these are the other important information you can get through your geophysics. When we move to geomechanics, geomechanics is a theoretical and applied science of a mechanical behavior of the geological material. Each geological formation in a subsurface is subject to stresses caused by a variety of natural factors. These include deposition, which causes gravitational loading, tectonics, uplift, pressure, inflation, deflation, stress relaxation, and thermal effects. What is basically is a rock is being deposited and the stress on the rock, that's more of a geomechanics. So what that information, that stress information, you can divide it into various parameters into that, but that information is very useful to understand the failure, or to predict whether the failure will be occurring according to the accurately as possible, assess the risk and opportunities, and recommended the mitigation plan. So if you know certain areas it's been a weak plane, you can change your project to a certain other area. So you need all of that. It can be megascopically, it's in the larger area, or it can be very small area. You can get all that geomechanics details. So when we say a rock mechanics, it's a rock mass characterization and a rock mass mechanics. It can also comes from the soil mechanics as well. So when the soil mechanics, it's a behavior of a soil from a small scale to landslide scale. So you can see that the soil mechanics, even in your slope stability or in your concrete as well. So that's the importance of the rock mechanics. So for example, I'm just showing a rock mass characterization, fault joints, clay layers. So you can see these are the weak planes where it's more of the faults is being happen due to the stress. When you look on this particular picture, you can see the interlayered clayey or very shaly layers as well as the sandstone layers. So you can calculate the strength of the entire rock mass or the weakness of the rock mass, and you can get all that information passed on to a civil engineering construction integration. So if you integrate all of that information, you can see or you can construct where the best possible sites. So how geomechanics applied in civil engineering? Apply soil mechanics principles to the solution of engineering problems related to stability of the foundations, walls and slopes. Other areas include a concept of effective and total stress in saturated soils, estimate elastic stress changes in soil, and calculate the elastic settlement under a variety of external loading systems. So these are all the viscosity of the entire rock, it's been plastic or elastic. So whether it's failure, you can calculate all these things into the rock masses and tell about the risk factors. And that can be leads to good projects. So this is one of them I'm showing where your stress increases, horizontal stress or vertical stress increases or reduces with it. That can be a hydraulic fracture or like a fault slip, expansion of the aquifer rock with a lot of water in it, which is more of plastic rather than elastic. So all these can be, all this information can be collected from a geologist and integrate with civil engineering. Next one is a petrophysics. So in petrophysics, to characterize the subsurface successfully requires physical sample, resistivity, electrical, nuclear, and magnetic measurements made through the subsurface logging, coring, and drilling the wireline tools or wireline logs. we usually call a term like a formation evaluation. We look into the details of that logs and analyze mostly on the petrophysical properties of these rocks. That also one of the major information into civil engineering projects. So logging tools to understand the rock, lithology parameters, soil characteristic, and the geotechnical properties of the soil material influence electrical measurements, so that you can easily understand what are the main rock or soil characteristics underneath. Petrophysical properties that inherently affect the mechanical and strength behavior of the samples. That's fine content, pore size parameters, specific surface area, and fractal dimension of the grain size distribution were obtained from geotechnical analysis. So again, there are a lot of information you can collect from a petrophysical logging tools or petrophysical analysis. So this particular picture shows a schematic diagram showing that from the core data what you can collect, and from wireline data what you can collect, like a core data, subsurface lithology, petrography, wireline data, caliper, gamma, density, resistivity, formation, pressure, and fluids. That's all we put it into petrophysical evaluation. Then final products comes from us like lithology, porosity, water saturation, permeability, which is more important in your projects. This is another two diagrams showing the first one, which shows from the gamma interpretation in a borehole, showing especially on the yellow one, which shows the sandy part, and other parts which is more shaly. Then this can be taken into a model which shows you can put your lithology. What my lithology is like various different types of rocks. Then that rocks can be converted into a 3D model, geologic model. Then you can see where these different rock types or different strata, where it's thinning out or pinching out or extended or thicker or whatever. And you can also calculate other parameters from this 3D model as well. So this is another detailed information you can get it for civil engineering projects. Now moving to geochemistry. So in geochemistry, this is more of like a rock, mineral, and fluid interaction. That's more of geochemistry, and also included within the clay mineralogy as well. And it's control in degree of consolidation of the rocks. So it's like a compacted or less compacted, and what type of minerals, then like reactions happen within that rock. So one of the application of soil chemistry in chemical grouting and soil stabilization. So before moving to some of other points, I would like to show you the importance of clay in geotechnical engineering. So if there is more clay in a rock or in a geological mass, two things can happen. It can hold the entire volume as well as the water content. So Y is volume and X is water content. So you can see if it is like a full volume and have higher amount of water, it's more of plastic. If that draws down to half of it, the water is being expelled or it's been extracted out of that entire clay, then it's more of solid. Then that's where it start to shrinkage, or it start to crack. Before it's like a plastic or liquid amount and the semi-solid part. So this is where you can get information. Again, it can be applied to your any of your constructions to see what the pore spaces available in the rock, and what is that filled with the pore spaces are filled with the water, and what that and percentage of the clay in it, and how that's been behaved in your construction. So next, the geochemistry also can be used for the environmental remediation and waste management, development of geologically optimal method to improve civil engineering projects of geological formations. So you can see like hazardous sediments and like not hazardous sediments, or like, I mean, if it is being reacted or the waste is reacted, what happens? Or can be easily disposable in a certain area, or to be confined to a certain disposal area only. So we can get all this information from geochemistry. So significant geochemical properties and process of soils, rocks, and groundwater is in understanding and development of effective and potentially sustainable geosystems during civil engineering projects. I like this one because this is more important in the present day environment. You have to be more potentially sustainable geosystem to be adopted or included. So we need more information or geochemical information to get that things, to understand the potential sustainable geosystems in your engineering projects. For example, this is one of the diagram I like most. This is in a dam site or an area where you are throwing all your waste. So there are three different colors I'm going to introduce you. This is one, which is a coarse waste rock, which is a reactive rock. Then, which is like a bit more of whitish, which is non-reactive. It's also a waste rock. And in between, there is a fine material, it's non-reactive. So if it is disposed with a similar kind of waste management, when you see, when the rains comes, your water percolation through these ones and comes to the groundwater without polluting the groundwater. Think about if this is like, I mean, these three areas where it's been reactive waste rock, and when the water goes through that, and if it is being coming through or percolated out and going to the groundwater, we are totally, I mean, giving the groundwater totally, now it's a waste, or like, I mean, it's a poisonous groundwater, or it's not a drinkable one. So this is the one of the management system you need to be adopted according to integration of geochemical as well as through the engineering projects. And also you can see the geochemistry is also applicable in corrosion and its consequences for reinforced concrete structures, swelling concrete in dams and hydraulic structures. So that's also easily be, can be done according to information in this last figure. So what are the things you need to look into? Is it the carbonate content in these ones? It's any primary metals that going to be reactive, or trace metals, pH, oxygen availability, salts and major ions. That's all a system of geochemistry. Then that's all goes to your chemical reaction energy availability area. Then you can also think about the microbial activity as well. So all this information leads you to a better construction, better projects on civil engineering. So now I'm moving to an area we are more specific on the rock and the mineralogy. Sorry. So here what I have put it, petrologists see the rock so closely than anyone else. They put it into microscope and they look the rock so closely. And rocks never lie as well. They'll tell you the truth. You can see what in the rock, and you can get all that information one by one to help your colleagues in civil engineering to get a better projects. So where do you get all this information from? That comes from rock typing, thin section, QXRD or quantitative X-ray diffraction, scanning electron microscopy. And I put it what all the information you can collected from all these different analysis. Everything comes together. That's for a petrology and mineralogy evaluation. Then, I mean, before I move to something else, I'll show you some of the thin sections and the scanning electron microscopy. So this is the first thin section photographs showing all the whites. It's quartz, the layer of some of the carbon, or we say hydrocarbon, or like some of the maybe pyritized. Some of the other ones is like feldspar. This yellowish one is more of feldspar grains. And all these light colored greenish, bluish ones, it's clay. And you can see some of the blue in between, that's pore spaces. So you can see the total raw composition, what it is and how that's formed. And on SEM, you can see the clay material and the grains, and you can see how the distribution is. And then the third one, this is a SEM analysis, or the scanning electron microscopy, showing this is a pore space, these are grains, and these are clay mineralogy, or the clay in between. So what do you think? If I'm going to give some stress, how this is going to be react on that? So that's a variation, or that's how you talk about more of the strength of geomechanics, geophysics of these rocks. So we can tell more clearly from a petrologist point of view. And that's integration. You can integrate all the petrology data into various disciplines, what we discussed just before, through structural geology to geomechanics to geochemistry to petrophysics, geophysics, hydrology. All can be seen through a petrologist point of view and give all this information. Now, I'm moving to, so once I finish all this significance of geology and civil engineering, I'm moving to recent research areas where they are integrating more geology into civil engineering. So technological innovation based on the inheritance, integration, and evolution of a fundamental technology for the development and maintenance of infrastructure, disaster prevention, earth resources exploration and development, and the use of natural resources and energy. These are the more technical innovations on in our latest, or like, I mean, for the last 10 years or so, they are much more developed in these areas. So which are like urban and landscape design, slope stability and landslides, innovative applications of geophysics, integrating petrology, integrating geologic models, infrastructure innovations. So we will talk all this about each one of that in coming slides. So in my first one, landslides, urban and landscape design, this is like where you to integrate creatively a beautiful landscape and cultural environment based on rich water, green, and the land. Landscape involves habitat, cultural climate, and the geographical field. It means the integration of natural and cultural environment of mankind. And I hope you all agree with that. So utilizing all of that, when you do the landscape design, you know, this is one of the waterways. You still keep all your greenery, everything, but your constructions and everything according to the cultural climate, geographical field, you are integrating everything into that. One of the other one, the second one, even though you are building multi-story buildings or high-rise buildings, still you are keeping your entire design with respect to, or you are addressing to the geographical terrains with respect to the surface runoff, water percolation, everything, and more of a greenery. So you need all of that. These are the areas in the present or in the last 10 years being very much developed in integrating geological information with respect to the civil engineering. The focus is on the concepts of landform equilibrium, geomorphological process response systems, geohazards, climate and lithologically controlled landscapes, and complex landform assemblages. That's all been taken consideration on these urban and landscape designs. So what's the result? Making to improve social health, strengthen community, and increase civic engagement. So people feel so free, and they will be happy, and they don't think about a situation. They are in a panic situation. So they are more eco-friendly. We all talk about all these things, eco-friendly or community-friendly or environment-friendly. We can do all of these things if you do a proper designing with all the geological available information with the engineering properties. So next one, I'm talking about slope stability and landslides. So assessment of integrated geological properties like shear strength of material, particle size distribution, density, permeability, moisture content, plasticity, and angle of response affecting the slope failure. Slope stability from a hydrological perspective, what we are looking? We are looking in the hydrological perspective, it's like integrated hydrological model, which is like a hill slope hydrology and stability for civil construction at landslide areas. So when you look in detail about these things, we can still build good civil constructions in that area. So my third point, where or when and where exactly can a slope become triggered to slide and flow downwards? Can we predict? Can we infer the things? Yes, we can, by addressing the landslide hydrology from both earth science and the soil mechanics perspective, can infer the hydrological process in hill slope and their influences of behavior and triggering the landslides and vice versa. So yeah, you can see, if you do a good study on the geological information, you can tell about these things. I put two pictures. In the first one, there's three ones. I'm showing the differences in shear and normal components of the gravitational force on slope with the different steepness. You can see the different steepness and where that is going to be more landslide happens. So if you do a proper studies and to understand how detached this material from each other and the rock stability with respect to the moisture, that's what I've shown in the second picture. This is a purely dry one, bit moist and saturated. So where do you think the slope stability weakness or like the failure can happen? Definitely on the third one, which is like here the pore spaces are filled with more water. Here there is not much pore spaces. So if you go through a petrologist, they can tell about the area. When there is a raining period, how much of the water is being collected in these rocks and where that landslides can happen. So mass movements initiate changes in hydraulic character of the soil, which are important for better understanding of short and long-term hydrogeomorphic responses of soil and hill slopes, which means, again, this is like, I mean, our climates of like dry and wet. So what the response, if you learn or if you study on these things, you can tell about how much that can be, where the slopes failure can be, or how much can it hold the water content. And in petrophysical wireline tools used interpretation of subsurface stratigraphic correlation and slope stability as well. You can talk more about all these new methods putting into slope stability studies to understand a better way. So for example, in this my third figure, I'm talking air slope and the root systems and infiltration and the groundwater table and the rainy times and the wind and evaporation transpiration all these information, if I'm getting, I can tell that the red dot denotes that this is the failure I'm going to predict. And if the amount of water at this system, it can be easily displayed. So the landslide most probably happened from that area. So similarly, you can infer in any slope conditions, on vegetation conditions. So all these you needed in and more studies has been done in these areas in last very recently. More papers are comes from in landslide, the stability, slope stability and landslides, and especially states like Kerala or Tamil Nadu or Karnataka. Most of the states, I think in northeastern to northern states, they all need all these sort of studies to understand a better way and to mark down where and why. And again, if you've done as a study now, it's not going to be the permanent. It can change us. The trees grows, more vegetation comes, so it changes. And the weathering process can change the patterns. The thickness of the weathering or the bedrock can be changes in time to time. So you need to be the regular studies being conducted to say that now this was a severe area or a light area. You can make it in your risk analysis factor. So next one, other area of innovative application, geophysics in civil engineering. And especially again, mostly done in the rock, slope stability or cliff stability. So this what I'm saying is cliff stability assessment using electrical resistivity tomography. Here they are talking about the reading or the data they comes up with dry fractures with a moderate mass movement potential, regions or low resistivity zones with the wet and clay, filled with the fractures with a high mass movement potential. So these are the other area you can put your geophysical information to get all this done. So for example, I'm showing a tomography, 3D resistivity tomography showing with the color combination with the low to high resistivity. So reading on the resistivity, you can tell, oh, I can see more of a slope failure over here or here. So these are the area you can map out clearly to say, yep, these are the potential areas for landslides. So this is one of the area now more studies or new research has been developed. So next one, determination of soil permeability using acoustic technique. Estimated porosity and permeability constructed from a characteristic frequency through an inversion process using data on sound propagation near to the soil surface and through the soil surface. Which means a symbol like that, you take a frequency and there is a characteristic frequency which tells you more about your porosity permeability in that rock. It's easy to understand how much of the pore spaces are there if it is in a dry condition, and how much of the water can be percolated through and be held there, or like filling the pore spaces. So these are the geophysical, analysis can be done in these areas. Geophysical application to construction engineering projects. Geophysical assessment for foundation design, mapping overburden and soil thicknesses for site grading and volumetric calculation of expected construction fill and spoil, characterizing geology beneath waterways for optimizing pipeline crossing, and mapping potentially hazardous abandoned mine workings as well. So these are the areas, again, like they're using geophysical applications to construct or to rectify things easily, or like to do a better project management on these areas. The other area, it's integrating petrology in civil engineering. So it's like this is one of the project, like a integration of underground mapping, petrology, and high resolution microseismicity analysis to characterize weak geotechnical zones. Integrating petrology and geomechanics produce many features, rock behavior, including elasticity, fracturing, acoustic emission, damage accumulation producing material anisotropy, hysteresis, dilation, post-peak softening, and strength increase with confinement. So this is an example where like a underground mine with a stop and characterizing what around that stop, and thinking of like the vertical and horizontal stress on it, and the features, the geological features, and where is the weaker zones where it can be any fracturing or displacement can happen. So integrating petrology and geochemistry provides secondary deposits, geochemical reactions, or the concrete components, soil and rock stability, degree of carbonation in rocks, petrographic analysis on the condition of concrete structures such as air content and distribution, aggregate information, cracking and chemical attacks. The other one is like a durability assessment of the rock construction materials. In this figure, I'm showing a thin section photograph showing the compaction of the rock. You can see this triangle junction, which is showing or indicates it's having highly compacted. So this rock has got a more strength than the next one. Next, why it is having lesser strength? Because there is a clay content running through the rock. That's a weak plane where it can be slips or it can give any fault in that one. And this one, you can see the difference in the grain sizes, very fine and larger grain size, where this can also be less strength than the one in A or B. So that's how we get more information from the petrology to in the construction sites to say, yep, there is a weak plane, or this is a area where we are not at all interested. We have to move from there to a different location, or you have to go through the risk analysis table to say, yep, we can construct, but we need to do certain other precautions or other management to rectify the things. Thin section images processing technique for porosity and permeability estimation in rocks and soils. That's a other new development area where you get the thin sections and you are automated mineralogy and petrology of a fine-grained layered rock using scan electron microscopy. So you scan all of that, and this color denotes the mineral composition, and you can easily put that into 100% of volume, the total rock, to say what's the major mineral component in each one of these rocks. And you can tell about what the best rock or the best area where you can use the rocks for the construction or not. So it's again, it's mixed with the clay or fully rock, rock grains, or it's different layered or stratified or anything. You can get a lot of information from all these analysis. So next one, integrating geologic models and artificial intelligence. That's one of the area very recently, like within last 2 to 3 years time. It's a vast advancing research area. And I like that. It's an like integration of all the data from all the projects totally happen. You can manipulate, you can define various variables with respect to see the best risk analysis or the best decision making. So in artificial intelligence approved to provide a high level of competency in solving many geotechnical properties applying in civil engineering problems that are beyond the computational capability of classical mathematics and traditional procedures. We can get a lot of information. We can slice and dice. That's what we say. We can look with this information to that information. We can mix all different variables instead of X and Y tables. You can get each and every single variables and to say, oh, this is the main factor which is controlling this particular structure. Similarly, so that's a power of artificial intelligence or machine learning in these days. The workflow and software system brings together structured and unstructured data and interpretation from type data to all types of geological, geophysical, rock property, geotechnical, mine production, fixed plan, mobile equipment, and mine geometry data to provide a data fusion capability and specifically aimed at applying machine learning to rock engineering problems. So you can look all this through all your data easily. So again, how that can be happen? It's like through artificial neural networks for rock and soil cutting slopes, stability condition prediction, site characterization, etc., etc., anything, etc., etc. So if you bring all that into your artificial neural network, if you add more variables into that neural network, you can extrapolate, or you can define it very clearly to say, oh, these are the main things I want to look into this particular project. And again, the geologic model for permeability and porosity characterization of clay under different hydraulic gradient. Usually you don't mix with different steps or different ways. You can do all that in different hydraulic gradient with the aid of artificial intelligence. And instead of hydraulic, you can also bring geomechanics, you can bring geophysics, everything. And using emerging new technologies for data acquisition, processing, and analysis in 3D geological modeling as well. So I just put a few points to say that, like, what do you do with your models? Engineering geologic model, it's more of like the information comes from the ground or the geological model that what we anticipate. Then you get all this information from your ground model or from your engineering details. So you put all these two together, you get an analytical model. Based on the geological model and the ground model, formulate suit the analytical method. So that then you start to analyzing it and to create a better projects or better designing of your project according to all these models. So this is an example for a neural network showing that, like, you put all this information like a geological observation, conceptual model, mathematical model, different geometric model, fundamental, geologic, all these things. So finally, you come up with an approximation of reality where you can understand a better designing, or like a real designing projects in such a way that to show you are gone through various other models and this is the best out of that, or best most likely. So you can bring up with a different models and come with the best model. I'll take you to one of the case study that's I read recently. It comes from a project from Slovenia, a tunnel projects from Karawanke, where you can see their work model. They initially bought the Landsat pictures and all the geological informations they collected. Then they transferred to the digitization of maps and drawings. Then to the digitization of the cross sections with the geologic informations. What are the rock types, rock different areas. And they all incorporated into the 3D geological model. That tells you more about your tunnel. Like when you put a tunnel, you can say, okay, I've been going through a type of rock here, the another one, the next. So I can easily plan differently with rock types, where it is like less fractured, more strength, less weakness. You can get all this information and you can plan very wisely or like efficiently according to your rock types. And all that fractures or that geological structures can be easily pointed out from that geological model. And also your rock mass characterization. and even the planning will be done very efficiently. So I like this. Like, I mean, that's sort of a powerful analysis or powerful model can be made in 3D geological models. So now I'm moving to last of my recent analysis or recent research areas were like infrastructure innovation in civil engineering using the geology. Manage civil infrastructure smartly, how that can be. So developing effective methods to identify change in health condition of bridges, how that can be. Impact and severity of traffic on ground motion, which is investigated by a newly developed analytical method that considers interaction of vehicle bridge ground motions. So that sort of analysis, and what the result is, like health monitoring of short and medium span bridges. So you'll be doing a understanding of what my construction, what my project was, and how that's utilized for my monitoring of the short-term and medium span bridges. And that can be easily passed to new other projects as well. So that's how you can develop or manage a civil structure smartly. Automated acoustic scanning of the concrete bridge decks and delamination identification. So that's another one. We can do the acoustic scanning and to see void spaces and all of that. The performance studies of the microbial induced calcite precipitation to prevent the erosion of internally unstable granular soils. So that's another one, which is using geochemical and petrology into that to see all, how that can be long-lasted ones rather than any erosion. Comparison of different foundation concepts using geologic information. If ground is initially improved by the vibro replacement technique, then the final cementation of the stone columns produce deep foundation elements. Improves the confidences in constructional design by using geophysical data, showing how to achieve and provide useful information that can be obtained on ground structure and in estimating geotechnical parameters directly from geophysics. That's again using the geology or geological information to make the infrastructure smartly. Distinguish the long-term behavior of elastic plastic structures subject to repeated moving on the surface loads, or designing 2-layered or 4-layered pavements. This is also important. The traffic intensity and again, the elastic plastic structures. And these are other areas where more recent research has been done. So by that, I'm finished my talk, and these are some of my references for the students. So I'm going to stop my talk, but before to that, I want you all make agree this one. Now, civil engineers and geologists are rocks. Hope everyone agrees with that. Thank you. And it's a time for question and answers, and I'm happy to take any of your questions.
Thank you very much,
Thanks a
sir.
lot.
Dear
So I
participants,
request students to please kindly post your queries on the chat box, and we shall read it out.
Oh, that's great. Thank you.
feel free to ask your queries. And also, if there is anyone to fill the feedback form, please fill it. I'll share the link again.
It need not be your doubts also. It can be your, ideas or your apprehensions about your higher studies, anything. Anything, feel free to put it. I think all have completely understood it. Anybody, please? Yes, sir. So we have got a question from Giri, who is our fourth
Yep.
year civil engineering student. So he's asking, which is better, studying in India or abroad, especially for structural
Oh,
engineering?
that's a great question. I always answering that question to at last 10 years. What do you like to study? That's the first question I want to ask him back. Like, I mean, there are very good teachers in India. There's a very good infrastructure in India. I would like to make a comment on that is about if you want to proceed with the same discipline for a master's or like a a postgraduate study, you can stay in India. But if you want to look for a research type studies, you can apply to the institutions in abroad. There are a lot of institutions in America, Europe, Australia. They all give scholarships. So if they think you are worth, you are real, genuine, interested. I don't say you are needs to be so bright. No, you don't need to be so bright. You can be a genuine person, an interested person, and you show your interest, then they can take you. For that, first thing you need to do is during your, don't think everything going to happen in the same day. You have to give some time. So if you're thinking a year in advance, you look other institutions around the world and you start to chatting with the process there. They will be all happy. Like, I mean, to my experience, I've seen if you write to anyone, anywhere else in the world, they will write back to you. They will suggest you something. So if you make a connection with all these people, that's a way you can get into a research sort of advanced studies. For those sort of advanced studies, you come out from India and to do a better job rather than, and again, you know, if you are coming to a country like Australia, you have to spend a lot of money. I don't know whether you will be able to do it or not, but still I say there are institutions in India itself. And when I talk to your teachers, they are much more knowledgeable than me. They are smarter than me. So I'm jealous about them. Really, I'm jealous about them. They can teach you a great things. So to my suggestion, study there, get a master's degree, then you come out for research or something like that. Or you can change your courses. When you come out, you can change. Even though you did a master's in India, for example, if you come to Australia, there is of mining management with the constraint geology and civil engineering. So you can do that because here it's a lot of jobs available in that condition. Even in India too, there are a lot of mines in India. So are we doing a smart way? No, probably not. So they don't need, they are not having enough a good degree holders like that, waste management and all of these things. So once they I mean, you guys, I mean, when the people, when the students are available or the graduated students are, graduated peoples are available, then they will hire you. So yeah, think about at least a year or two in advance, what I need to do. Hope that clarifies his question.
Sir, thank you, sir. Thank you for the answer. And thank you, Giri, for asking the question. So we'll move on to the next question, which is asked by Dr. Sainu Franco. So his question is, how is petrographic analysis done and what equipment is available for this petrographic analysis? How is underground mapping done and what is waste rock? So 4 questions, sir.
Oh, okay. I'll repeat the questions what I know. One is like a petrography. How did you or how could you make your petrographic data acquisition? Second thing is like the underground mapping. Third thing?
What is waste rock? And 4th question is what equipment is available for petrographic analysis?
Okay.
We can take question by question also, sir.
Okay, so I'll talk about the petrography. So petrography needs a microscope, an optical microscope, where you can see different optical resolutions as well as like a magnification. And the optical property tells you about your rock. That's how you get all this information. And you can collect a lot of information. Even I can send a sheet where what sort of information is gathered from a thin section, so that Sainu can understand what all the informations. And the rock, it's going to be cut into 0.3 millimeters and overlaid on a glass slide to look through the microscope. And the microscope costs like around, I don't know exactly what is in India, but it costs you like around 10 to 15 lakhs to, it can goes to higher resolution, higher things, it can goes to 1 crore. So mostly it doesn't need for a student or a teacher to go through that sophisticated microscope. Then underground mapping, which is more of like these days we are doing seismically. So we go through the seismic acquisition and understand the rock layers. The second one, it's petrophysics. We put a drill holes and we do the logging, and logging through the logging, we can understand what type of rocks in that particular layer. When I said it's like a bad rock, you know, bedrock or bad rock? Is it the question a bedrock or a bad rock?
No, sir. The question is waste rock.
Waste rock. Okay. Waste rock means that's mostly in mining sites. It's like when you are mining.
Waste rock.
Waste rock, yeah. When you are mining, for example, gold or a copper or iron, you have to move or you have to excavate all the overburden material. So overburden material is more of waste rock. So that has to be properly, waste management has to be done. Even if you are looking for gold or copper, it is not just filling us entire strata. It's like a different form. So when they're taken out, they're crushing it, and the extract or they're taken with a different remedification model, they take all the minerals and the rest is being thrown out as a waste material, waste rock. So that has to be dumped again in certain mine sites. Again, you need a waste management to be done on that ones. And that's one of the area in Australia in the recent advanced research is happening. So hope I explained that for them, petrology, how to get the petrology of thin section and what is the instrument used for, and how do the ground mapping, and the fourth one is like a waste rock. Yeah.
Thank you, sir. We have another question from Radiban Bora. It is like, what is the future of geothermal energy in India?
Oh, that's a real great question. So again, you need in the geothermal, you have to drill down to get a rock which has got at least 120 to 150 degrees centigrade. You are pumping that water and circulating through that rock and bringing up to get a temperature more than 100 degrees to run the turbines. So in India, there are very good scope because the granite, most of the granites in Eastern and Western Ghats, they are allowing all these things. But again, I don't know exactly how much that being developed in India, but that's one of the area. Why I said there's a big scope. Australia, they are on that road, like they are constructed, I think 3 or 4 major projects on geothermal projects in Australia. So Australia and in India, the geology is almost the same. And I can see even in South India, you got a lot of granitic rock where, especially in Tamil Nadu, there can be drill into that and circulate the water back and get the high temperature for generation of, geothermal.
Sir, we have another question again from Dr. Sinu Franco. How do you identify the locations for safe disposal of hazardous waste materials?
That's a good question. Again, that depends on your entire area. Like, I mean, there is no a particular area. We have to construct it. Like, I mean, one of the figures I showed where here, this is the one of the area. This is not a safest place. Like, but you excavate the entire area and start to filling in such a way that systematically to restrict any of the hazardous situation happens. Like, I mean, the percolation of water. It's like they put it all the reactive material together, and in between the reactive material, they provided non-reactive and compacted material. In compacted material, there won't be water flowing, or even if the water flows, it flows in that through the similar strata rather than to the reactive rock. So you have to make it sure that in an area where the groundwater is so deep, and it's even though the rainwater doesn't flow through the entire waste rock or waste disposal area, and that's been leached out and going through any of the aquifers below that, or you have to restrict that. So you have to make it a suitable area rather than there is no particular suitable position in the earth.
Thank you,
so
sir.
I hope she can understand. Otherwise, we can talk, Sainu.
Okay. Dr. Sanu, maybe you can contact directly to sir. We'll share the sir's mail ID also.
Yes, thank you, sir. And anybody more for any queries? You need not, even if you want to directly have a chat
Madam,
with sir also. Yes, sir.
There is a question from our HOD, Dr. Arun Kumar, sir.
Yes,
Sir,
sir.
please throw some light on the opportunities if a student is interested in geology, because many of the students want to know about that. He's our HOD of civil engineering.
It's integrating civil engineering. Yeah, I mean, definitely. Like, I mean, I don't know. I mean, again, the curriculum in Indian universities, but most of the, even I had only, I like to be a teacher. I love the teaching. I had only 4 years experience, but in that 4 years experience, in every year there is a basic curriculum, but again we change according to the present job marketing or job market. So if you are looking for people from a discipline, we more highlight or more we give them weightage more to that area. So similarly, this is one of my suggestions, where to incorporating different areas of geology into civil engineering, like in the 3rd year or 4th year, you can specialize, or I don't know whether in Australia, we can get a double degree, which means like people take civil engineering plus engineering geology, or civil engineering plus geotechnical engineering. So they have to learn 5 years in such a way that they study both the subjects, and they need to be passed for a certain amount of points. So if they have got that certain points, they will allow to get the double degree. I don't know whether in India there's a possibility of doing that way. Otherwise, in civil engineering, you have to add on the 4th year or 5th year more of like integrating different disciplines of geology. So if someone are more interested on landslides, stope stability, or hydro dams and all of that, the hydrological things can be incorporated into that. Or like some more of geophysics, geomechanics, that's more of mine sites, any other main features like a dam, tunnels, anything like that as well. So we can integrate all that subjects in the 3rd or 4th year. That's all my suggestions.
So just adding to that, some of the Indian universities are having that possibility. For example, in VIT, we are having such a system. I mean,
Okay.
in different specializations. I mean, they had to take some maybe 3 to 4 courses extra.
That's right.
And then they'll be having that particular specialization in their degree certificate. For example, civil engineering with specialization in structural engineering, or honors in structural engineering, like that.
Okay.
But they had to do some extra courses.
That's right.
The possibility. Some universities are allowing that one.
Oh, that's great. That's one of the new. It's been appreciated and to be encouraged, because that's one of the area the people can integrate. In the present day scenario, there's no subject as it's standalone. It's all integrating. They are like, that's what I said, like the artificial intelligence and machine learning allows you to integrate all the information from different disciplines, and you can mix, match and things. And you can take what you like, or you look on the information, what you can really want it. I can just throw all other things. This is the core, I can take it. Before, sometimes you get all the information, sometimes you don't get information, sometimes it's not lacking more information into the projects. But these days it's like there are a lot of. So yeah, that's a good idea to take a civil engineering with the geotechnical engineering as a specialization, or like a geomechanics or geophysics as a things, or infrastructure, capability, or any that kind. Yeah. So yeah, it's a possible there.
Okay, sir. Thanks a lot, sir. So I hope all doubts are being cleared, and give us your mail ID also, so that students and everybody, all participants, can approach you if in future if they have any queries, sir.
No
that
worries.
would be great from our side. Yes.
One of my suggestion I want to make, it's like, I said the present time we are all like there should not be a communication gap. Even as a teacher, as a student, ask students to talk. I'll tell you a experience in my life. As Indians, most of the Indians, they are not willing to talk much. They are silent listeners. They are bright students. They do the great job. But who wants it? No one wants it. The people who get the higher ranking, only the people who talks. So make them to talk now. Make them to open their mouths. It doesn't matter whether it's even in Australia we say it's a bullshit or it's a thing or whatever. Just ask them to talk. Then
we are in same lines as you are.
Pardon?
No, we are in the same line and frequency as you think, sir. But again, see, they have their own inhibitions, but slowly we are cutting it off, as you rightly said.
Very good, very good.
Sir.
Like, yeah, that's only I say, like, the Europeans or Americans, they don't do the work. They take the work of what Indians or Asians do, and they show, yeah. And end of the presentation, we think, oh, he did all this work. No, he only talk. So ask the students to talk. It doesn't matter. Give them in hour of teaching. Give them 45 minutes of talking. You talk. Teachers only talk 15 minutes. Make them to talk.
Yes, sir. We shall do it. Sir.
No worries.
And thank you, sir, for giving us a good suggestion. Yes, sir. So shall I call Bensi Ashok? Bensi?
Yes, ma'am. I'm there.
Kindly felicitate, sir.
So, good afternoon to one and all present in the meeting. I'm Bensi. It's my privilege to thank Dr. Saju Menacherry, who spared his valuable time in his busy schedule. Sir, as a civil engineering student, I really felt all the points about the significance of geology and the research area were really valuable. Sir, you really gave a deep information about a geologist as a civil engineer look for. You made us clear about all the geological features, data, characterization of civil or of structural, hydrological, geophysical, and geomechanical, etc. With a suitable diagram. This was really helpful for us, sir. Recent research area in urban landscape design, slope stability, landslide made us understand that what are the considerations we should take before implementing a civil engineering project. Application of geophysics, petrology in civil engineering was informative. Artificial intelligence is the only thing all the engineers look for. Integrating it with geology gave us information that even geology can be implemented in machine learning. Thank you, sir, for clearing all our doubts. Hope we reach out to you in future. Sir, you really made us to agree that all the civil engineers and geologists are rock stars. I thank our coordinators, Dr. Anjali and Dr. Gautam, and our faculty, Dr. Morgan, for providing us an opportunity and guiding to build future civil engineers. And I thank all the faculties and students for attending the seminar with patience. Thank you.
Just before closing down, I have to thank two of my students. Like one introduce me and one thank. I didn't remember the name of the two.
Anushka and Bensi.
So Anushka and Bensi Ashok.
Anushka and Bensi, thank you very much. I mean, that was a great introduction, and that's a great thank you, felicitation as well. Thank you very much, and I really enjoyed it. Like to talk and share my experience with you all, and to listen what you guys want to talk to me. Yeah, thanks a lot.
Yeah, thank you, sir. And before we wind up, I request all of you to please switch on your video. We shall just take a virtual photograph. Please switch on all your video so we'll just take a picture and we can all wind up there. And meanwhile, while you are all switching on the video, just brief about our 5th webinar series, which will happen next Thursday. So we have an eminent structural engineer who has got a lot of experience both in academics as well as other industry. So his name is John Kurian, Dr. John Kurian. So he'll be coming and giving you a very good insight about significance and prospects of structural engineering. Yes, thank you all for switching on the video. So we shall take a photo, a virtual photo, and then leave for the day. Yes, say cheese. Yeah. Okay. Thank you.
Thank you, everyone.
Thank you all, and thanks a lot, sir.
So I'm expecting more emails today itself.
Yes, sir. We are also hoping so. Yes, sir. Or else we'll collaborate, sir. Soon we'll collaborate each other, and we'll like have more discussions, more research-oriented discussions.
Thank you, my dear friend Mohan.
Thank you.
Thank
Sir,
you both.
you're on mute.
Yeah, thank you.
Okay.
Okay, bye.
Bye. Take care.
Thank you, sir. Thank you, everyone.
Okay, thank you. Yeah.
And all participants, those of you who have not, written the feedback, kindly please fill the feedback forms, because this will help you help us for initiating the e-certificates. Please fill up the feedback form, and you can kindly leave. See you all next Thursday.
I'm going to leave now. Okay.
Yes.
Okay, sir. Thank you. Thank you so much.
Yeah. Thank you so
Yeah,
much.
sir. Thank you, sir, and have a great day, sir.
Okay, thanks. Yeah, bye.